morning. My name is Todd Gage. I'm the product manager for Persistent Disk and Local SSD. I want to thank you all for joining us here this morning, especially at 9 a.m. after a big party last night. So here's what we're here to talk about today. We're going to talk a bit about Persistent Disk, some best practices, a little bit about our future performance, and then cover a whole bunch of new features, which I'm very excited to show you today. So for those of you who've been going to any of the storage sessions thus far, you've probably seen this slide. It gets a bit more complicated every year, a bit more like an eye chart every year. And so to help you out, here's where we are. We're looking in the storage section under block storage, and we're going to be talking about Persistent Disk. And Google Cloud Platform has 3 block storage products. Local SSD, which is physically attached, physically resident in the machine. This is ephemeral storage. If that machine goes down, we don't guarantee that that data remains. However, this is also the highest performance storage we have because it is physically resident in the machine. We have 2 flavors of persistent disk. Now, these are designed to be durable persistent storage. And the 2 flavors, we have one backed by standard hard drives, and that's really for cost-effective, high-volume storage. And then one backed by SSD, which is for your high-performance storage needs. I'm going to quickly talk about just sort of overall PD. Now, as I said, PD is a high-performance, durable block storage for any of your virtual instances, either on Google Kubernetes engine or Google Compute Engine. Presents itself as a virtual SCSI device, and it scales from 1 gigabyte all the way up to 64T. Persistent Disk supports multi-reader and read-only mode, which we'll talk about a bit in a moment. Snapshots, which again we'll cover in a moment, and scale, again going from 1 gig to 64T with the ability to grow while that disk is in use. And as you've probably heard throughout this week, security is a very key component of Google Cloud Platform, and so all of our data is encrypted at rest automatically, either via Google encryption keys or your own. We see a couple common patterns of behavior with persistent disk. This is the simplest. This could be your basic web server, WordPress, anything like that, where you just have one volume, one virtual machine. Another common pattern is a root disk and then some data. This could be your database instance, anything where you have working data. Again, not very complicated. This is where things get to be more interesting. This could be a big compute workload where you have one data disk, you put it in read-only mode, you shard out all that work to workers, and you don't actually have to multiply record that data. You just have all those instances point at one disk. And then finally, something again we'll talk about a bit more in a bit, is the ability to synchronously replicate data across 2 zones with a new offering that we're calling regional persistent disk. So persistent disk snapshots, I mentioned a second ago. Persistent disk snapshots are used for a number of things. One is just basic backup of your data. This data is critical to your business. You want to make sure that you have it around in case of future need. Snapshots are a great use for that. Disaster recovery. You want to insulate your business against disaster. You can take snapshots that are stored in a GCS multi-regional bucket, and that ensures you against the data loss in any one zone. And then finally, disk cloning. Snapshots allow you to really quickly replicate disks across multiple regions, multiple zones, and starting at the first disk is relatively fast, and every disk after that will be very fast. Now, here's a couple examples of snapshots in use. On the left, we have volume 1, and you see that we're taking snapshots at T1 through T4. Each of those snapshots is point in time, but it's also incremental, so you're only storing the additional data that you need from the previous snapshot. Now on the right, you see this user is taking a copy of disk 2, copy of volume 1 at time 2, and then also doing disk cloning at the bottom, making 3 copies of volume 1 at time 4, potentially for use across 3 different machines. Couple of best practices to go through this morning. One thing I didn't mention earlier, but you might have read on the slide, is that persistent disk gives you maximum performance without the need for RAID or striping across multiple volumes. Persistent disk performance is exclusively tied to the disk size. So we give you an allocation of I/O per gigabyte and bandwidth per gigabyte that increases linearly up to the bandwidth caps, or up to the caps. So unlike other platforms you may have seen, there's no additional need to add volumes for performance. Also, we really suggest you look at both your I/O size and queue depths. So for high IOPS workloads, we suggest 16 kilobyte block sizes or smaller, and larger I/O queue depths, which really help performance at those lower block sizes. Specifically, for high I/O, we suggest a queue depth of 1 for every 400 to 800 IOPS. Now, on the other side, on high throughput workloads, we suggest block sizes of 256K or larger, and enabling the read-ahead cache in the OS. Finally, we really suggest aligning your I/O to 4K boundaries. What you see on the right is an example of 6K writes at the top, how persistent disk sees this in the middle, and then how it's actually written to the volume on the bottom. And what's a little less apparent is that for every 6K write, you actually have to touch 2 blocks. So you're effectively doing 30% more disk access for the same amount of traffic. And where if you just aligned your writes to 4K boundaries, you can save those extra disk accesses. And now, very excited to share with you some announcements, starting with performance. Performance is the thing that we hear the most about from our customers. It's consistent in literally every customer conversation, and it's something that we're always focused on improving. As I said earlier, persistent disk comes in 2 flavors. We have standard persistent disk backed by HDD and SSD persistent disk. And then you can really see the stark difference in performance here. SSD doubles the IOPS on the right side and is more than an order of magnitude faster on reads. One thing to note, as I say in the corner here, this does require machines with 32 vCPUs or larger on the SSD side to achieve these IOPS. And now, I'm very, very excited to announce a 50% improvement in read performance for PD SSD. This increases our read IOPS to 60,000 and our bandwidth to 1.2 gigabytes. Now, some lucky few of you may have already seen this performance in production. But if you haven't, don't worry. It will be rolling out to all of PD SSD over the next couple of weeks, and I'm very, very excited to see people take advantage of it. Now, this isn't, as I said, we're always working on performance, and we're not stopping there. So we do have something in our performance labs that we're working on. And this is a number of changes kind of baked in together, but as you can see, we're getting all the way up to 100K IOPS and 1.6 gigabytes of bandwidth. And the most exciting thing for us is how that translates into real-world performance. On the right-hand side, you can see we did some read-only benchmarking against Postgres and Aerospike and saw almost a 30% improvement on Postgres and over a 40% improvement on Aerospike. Now, as I mentioned, in the lab, there's a couple of different changes going on, but as we dug into this, it looks like that performance change is primarily driven by the IOPS, and we're really excited to get this out. No promises yet, but as I said, it's something we're actively working on. And now, earlier I mentioned regional persistent disk, and now I'd like to talk about it in a little bit more detail. So regional persistent disk presents itself as a singular persistent disk to your virtual machine. However, on the back end, it is synchronously replicated across 2 zones. Regional persistent disk works either with Google Kubernetes engine or a Google Compute engine and allows you a single disk for high availability. One thing to note, regional persistent disk has all the performance of a persistent disk other than write bandwidth. Write bandwidth is halved because you're writing the data to 2 places, but otherwise the performance is exactly the same. So regional persistent disk really provides you a building block for building either disaster recovery solutions or high availability solutions, depending on what you need for your business. It improves durability and availability, and we've really spent time building this for mission critical applications. In fact, for any of you that are using Cloud SQL's high availability configuration, that is backed by regional persistent disk, and it has been a very successful product for us. This, as I note, is in beta and it's available today. You can just go to your instance, open a new disk, and you will see something like this. So this is the new UI. You can see that replicate this disk within a region. That changes the zone dropdown. And instead of zone, it's now zones. And you are able to select up to 2 zones in that region. So it's very, very straightforward to set up, almost as easy as setting up a normal persistent disk, but automatically gets you replication across these 2 zones. And now to show you a little bit more about regional persistent disk in practice, I'd like to introduce Saad Ali. He's the tech lead for Google Kubernetes Engine Storage.
All right, thank you very much, Todd. So my name is Saad Ali. I'm tech lead of GKE Storage, and I'm really, really excited about this regional persistent disk feature. Let me talk a little bit about it today. So, like Todd mentioned, regional persistent disks are a great building block for building HA applications. It'll automatically handle any storage level failures. It'll automatically fail over with lower latency, but it'll be invisible to you as an end user. But what happens if you have VM level failure? You have zonal failures and the VMs become unavailable. Normally you'd have an outage until somebody on your team notices and goes in and manually moves that workload over. It's nice that you have the replication across zones, but you still require manual intervention in order to make your application HA. Or you could build custom tooling that'll go ahead and monitor the virtual machines, monitor your application, and do the failover manually. But that's a lot of complicated tooling. Wouldn't it be nice if there was something that did this for you automatically? Kubernetes Engine. Google Kubernetes Engine handles all of this for you already. By a show of hands, how many of you are familiar with Kubernetes? That's what I like to see. And how many of you use GKE? Awesome. So with GKE, we do node-level health monitoring already for you, and we automatically will move your workloads if we detect that the node is unhealthy. And along with your workloads, we'll move your storage. You don't have to do a thing. So the next question is, how do you actually use this in Kubernetes? If you're familiar with Kubernetes, you've probably already seen the storage class API object. It enables Kubernetes cluster administrators to specify a template for provisioning new volumes. So when you as an end user want to use storage, you specify a storage class in your persistent volume object, and a new volume gets provisioned using that template. So to enable automatic provisioning of regional persistent disks, all you have to do is add a couple new parameters to your storage class. One is the replication type to indicate that you want a regional persistent disk, and the second is zones to indicate which zones you want your persistent disk to be replicated in. And then Kubernetes will automatically provision a new regional persistent disk for you, and you'll use it in exactly the same way you're used to using persistent volumes in Kubernetes today. So now let's take a look at how it's going to work in practice. So imagine you have 2 zones, and each has a single zone, and you have a workload that's running on the node in zone 1, and a replicated disk is attached to that workload. But now zone 1 suffers some sort of failure, and the node in zone 1 is no longer available. Kubernetes is automatically going to detect this, and it's going to terminate your app from the unhealthy zone and prepare it for moving, and it'll automatically detach the volume from the node in the first zone and attach it to the healthy node in the second zone. And move your workload over as well, and your stateful service basically automatically heals from a zonal failure without you having to intervene at all. You didn't have to write custom tooling, you didn't have to do any manual intervention. That's the beauty of regional persistent disks. So regional persistent disks are available as a beta feature starting with Kubernetes 1.10. Please try it out and let us know what you think. Thank you very much. Back to you, Todd.
Thank you, Saad. So I realized I didn't cover one key thing about regional persistent disk, which is it is available in both flavors of persistent disk. You can do regional persistent disk for a standard persistent disk or SSD persistent disk, depending on your business need. And now I want to talk about regional snapshots. Regional snapshots allow users for the first time to specify the locations that their snapshots land in. As I mentioned earlier, today, snapshots automatically get recorded in a GCS multi-regional bucket. And going forward, users will be able to select whether they wish a region or multi-regional bucket, and then can select any region or multi-region within the Google network. This really provides users a choice between whether they want insulation against disaster recovery or data residency, where you really need the data to stay in a single location for legal or regulatory reasons. This also, for the first time, means that snapshots are going to begin to charge for network transit. And so there's also a cost-effective play here, where if you want to avoid network transit, you can keep those snapshots exactly where the disk is, and all you pay for is the storage you're paying for today. If you have any interest in this whatsoever, please email pdinterest@google.com, and I'd be very, very happy to share with you more information. Here's an example of what this looks like in practice. I'm going to highlight the key features for you here. On the left-hand side, we see that we're setting up a regional snapshot, and I've selected the default, which is just have the snapshot reside in the exact same location as the disk. As I said earlier, this is a setup we see fairly commonly for data residency, data locality concerns, and or to drive costs down. On the right, you can see I'm selecting a multi-regional bucket and moving the data to the EU. And this would be, again, for disaster recovery, or if I know that I need to replicate that disk multiple times in the EU in the future, I can write that data to the EU once, and then replicate locally many, many times, again, for cost savings on the network transit. Your snapshot your snapshot list will also begin to change, and there's a new column here for location. It's the second column there. It just shows you where these snapshots reside. We're aware that people need snapshot management tools, and this will really help you find all of your snapshots based on location using the filter. Another exciting feature for snapshots that I'm happy to talk about is snapshot scheduling. Snapshot scheduling provides lifecycle management for your snapshots from creation to deletion. You can schedule per hour, by day, or by week. It supports snapshot locality. And again, if this is something that's of interest, please email pdinterest@google.com. And here's an example of setting up a daily schedule. And you can see selected a regional bucket, but then down in the frequency, selected every day at 3 o'clock. So this snapshot will kick off in that hour once a day, and then all of those snapshots will be deleted automatically 14 days later. In this instance, I'm setting up a weekly schedule. And as you see, I'm specifying the day of the week, and then which hour of that day I want the snapshot created. Now, what you can't see is on the bottom of the screen, there's still the auto-delete row. It just is off the screen. But every snapshot schedule includes an auto-deletion policy. I'm not going to show you the hourly schedule today, but it's very much in line with these two. However, what I will show you is how you attach a schedule to a disk. Now, at the top, you select the disk. Every disk today can only have one attached schedule. However, you can use a schedule for many, many disks. So if you know that you have some data that you want to back up every day, some data you want to back up every week, or don't have monthly yet, but it's in the works, or every hour, then you can set up those schedules singularly and then attach that to all the data disks that it applies to, so you don't have to manage many, many schedules. So again, If you have any questions about anything that you've seen today, please email pdinterest@google.com. That's for alpha signups, questions about best practices, or any other things you would like to know.